The quest to discover life beyond Earth has been a fundamental goal of space exploration from the very beginning. As our understanding of the planets and moons in our solar system has grown, scientists have identified several locations that could potentially support life. However, given the immense scale of space and the challenges of exploration, researchers must concentrate their efforts on the places most likely to harbor life. Mars. Despite its freezing temperatures, Mars remains the primary focus in the search for extraterrestrial life. More spacecraft have been sent to explore Mars than any other planet besides Earth, largely due to the possibility that it may have once, or even still, been capable of supporting life. Mars' surface is extremely cold, with average temperatures around minus 63 degrees Celsius, and the planet has a thin atmosphere with low pressure. These conditions make it impossible for liquid water to remain stable on the surface. Since all known life on Earth depends on liquid water, scientists prioritize the search for environments where water exists. Based on surface conditions alone, Mars does not appear to be a hospitable world for life. Europa. Jupiter's moon Europa is another leading candidate in the search for extraterrestrial life. Given its great distance from the Sun, temperatures on Europa are so frigid that water freezes into ice as hard as rock, making the surface seemingly inhospitable. However, powerful tidal forces from Jupiter's gravity generate heat within Europa's interior, allowing liquid water to exist beneath its frozen crust. Scientists believe Europa's underground ocean holds twice the amount of water found in all of Earth's oceans combined. Measurements of the moon's magnetic field suggest this water is salty, which indicate interaction with a rocky seabed, a potential source of energy that could support life. If this vast liquid ocean truly exists, it would make Europa one of the most promising places to search for life. However, many questions remain, including the exact thickness of the ice shell and the conditions beneath it. NASA's Europa Clipper mission, set to launch in 2024 and arrive at Jupiter in 2030, aims to confirm whether Europa's hidden ocean has a potential to sustain life. Enceladus, one of Saturn's moons, is an equally, if not more, compelling target in the search for extraterrestrial life compared to Europa. Like Europa, Enceladus has an icy shell covering a subsurface ocean that appears to be in contact with rocky seabed, potentially providing energy sources necessary for life. However, what sets Enceladus apart is how accessible its ocean is for study. At the moon's south pole, fissures in the ice expel towering plumes of water vapor into space. This unique feature makes it significantly easier to analyze Enceladus' ocean compared to Europa, where the water is buried beneath thick layers of ice. NASA's Cassini spacecraft took advantage of these plumes by flying through them multiple times between 2008 and 2015, using its instruments to study the water's composition. The analysis revealed various organic molecules, including phosphorus, an essential component for amino acids that had never before been detected in extraterrestrial oceans. While Cassini wasn't equipped to search for life, it proved that Enceladus plumes contain ingredients necessary for life. To determine whether living organisms exist beneath its icy shell, a dedicated mission would be required. One proposed concept, the Enceladus Life Finder, aims to directly search for biological signatures within the moon's plumes, bringing us closer to answering whether life exists beyond Earth. Venus. While Venus' surface is one of the most extreme environments in the solar system, the search for life on the planet is far from over. Venus has the hottest surface of any planet, even surpassing Mercury, despite being farther from the Sun, with surface temperatures reaching 470 degrees Celsius, hot enough to melt lead. Venus experiences a runaway greenhouse effect caused by its dense carbon dioxide atmosphere. This atmosphere, 54 times thicker than Earth's, traps heat and creates crushing surface pressures equivalent to being 1 kilometer underwater on Earth. Despite its current extreme conditions, Venus may have once been much more Earth-like. Scientists believe it could have had liquid water oceans and a temperate climate for up to 2 billion years, a long enough period for life to potentially emerge. If life exists on Venus today, it is unlikely to be found on the surface. Instead, attention has shifted to the upper atmosphere, where conditions are much milder. In 2020, Researchers announced the discovery of phosphine gas in Venus clouds, about 50 kilometers above the surface. On Earth, phosphine is typically associated with biological processes, raising intriguing questions about its source. However, the detection of phosphine has been heavily debated. Some studies challenged the initial findings, while others reaffirmed its presence but suggested non-biological explanations. More recently, phosphine was redetected at lower altitudes, adding further complexity to the mystery. Whether Venus' atmosphere harbors life remains an open question, one that future missions may help resolve. Titan, Saturn's largest moon and the second largest in the solar system after Jupiter's Ganymede, stands out as a unique and intriguing world. It is the only moon with substantial atmosphere and the only place beyond Earth known to have liquid on its surface. However, unlike Earth's water-based lakes and rivers, Titan's surface liquid is primarily methane, which collects in vast seas, rivers, and even falls as rain from the thick, hazy atmosphere. If liquid water exists on Titan, it would be buried deep beneath the icy surface, possibly emerging occasionally through cryovolcanoes before freezing rapidly. Whether Titan could support life remains uncertain, but the presence of liquid methane and ethane has led scientists to consider the possibility of methane-based life forms. Additionally, Titan's atmosphere produces tholins, complex, carbon-rich compounds that settle onto the surface, forming vast dune fields. If life could be based on methane instead of water, these tholins might serve as its building blocks. NASA's upcoming Dragonfly mission, set to launch in 2027, will explore Titan's potential for life, both past and present. Unlike traditional rovers, Dragonfly is a drone-like lander capable of flying short distances, allowing to investigate multiple locations across the moon. Its primary objectives are to determine if Titan has ever been habitable, analyze its complex chemistry, and search for possible signs of life.